Very good morning, children. I'm Deepa, your physical science teacher from Dr. Besant School. How are you all, children? Okay. See here, before starting the session, I want you all to be ready with your books. Okay? Your textbook, notebook, everything you should be ready. And in the last session, we have started our new chapter. What is that new chapter? Human eye and colorful world, isn't it? And what we learned in that last session? We learned least distance of distant vision. What is the value of least distance of distant vision? As 25 centimeters. Is it same for every person? No, it varies from person to person and even with age, isn't it? And also we learned angle of vision. Angle of vision for the healthy human eye is 60 degrees at an average age. So these are the topics we learned in the previous session. Structure of human eye and angle of vision, right? And least distance of distant vision and angle of vision. These are the two topics we learned in our previous session. Today's session, we are going to learn structure of human eye. Okay, children? So, this is the diagram of our human eye. Clear? So, now let us learn the parts. Actually, already you have learned about human eye in your NS. Isn't it? In 9th class, NS topic in biology, you learnt about human eye and also you learnt its parts also. Now here in this chapter, we does not require every part of this human eye. We are going to learn the major parts. Okay, major parts which are responsible for vision and that image formation. Okay, and the nerves which are responsible for transforming these signals to the brain. And again the brain will reverse the image position. Okay, all that we are going to learn. So some of the main parts we will see in this structure of human eye in this diagram. One of the important diagram, children, you should learn to practice this diagram. Okay, right. Now let us see the main parts here. See in your textbook, take page number 89, structure of human eye. You can see the diagram there in the textbook also. The human eye is one of the most important sense organs. Yes or no? Yes. It enables us to see the object and colors around us. What is the use of eye? It enables us to see the objects and also the colors which are around us. And this figure shows schematically the basic components of human eye. The eyeball is nearly, what shape is the eyeball? Yes, eyeball is spherical in shape. Eyeball is nearly spherical in shape. And the front portion is more sharply curved. You see the front portion? Complete eyeball, actually it is in spherical shape. And the front portion of this eye is more sharply curved and is covered by a transparent protective membrane. What is the transparent protective membrane called? This is the front portion which is more sharply covered. Okay, and it is covered by a transparent membrane. What is the transparent membrane called? It is called cornea. The transparent membrane is called cornea. It is this portion which is visible from outside. From outside which we are able to see the part that is called cornea, which is more sharply curved, protective membrane. And behind the cornea, there is a place filled with a liquid called aqueous humor. Behind cornea, there is a place. Okay, this place is filled with a fluid. What is that fluid called? Aqueous humor. It is filled with a liquid fluid called aqueous which is called aqueous humor. Behind cornea, there is a place filled with a liquid called aqueous humor. And behind this crystalline lens, which is responsible for image formation. So behind this empty space which is filled with liquid, behind that, what is there? See this portion. Okay, what is this? These are lens, crystalline lens. What is the use of this lens? The main responsible for the formation of image. Lens is the main responsible for the formation of image. For us to, we are able to see the object mainly because of this lens. And next, between the aqueous humor and the lens, we have a muscular diaphragm called iris, which has a small hole in it called pupil. See, between this aqueous humor and lens, there is another part. What is that? Which is a muscular diaphragm. You all know diaphragm, no? Which can be stretched and contrast. Okay, which will be doing up and down. That is called diaphragm. So there is a muscular diaphragm. What is that muscular diaphragm called? Iris. What is it called? This is what this iris. Okay, children? And this iris, which is having a small hole in it, which is called pupil. So iris is having a small hole in it called pupil. What is that small hole called? Pupil. Iris is the colored part that we see in an eye. Inside the eye, with the colored part, what we are seeing, that is what this iris. Okay? The pupil appears black. What is the color of the pupil? It appears black. Why? Because any light falling on it goes into the eye and there is almost no chance of light coming back to the outside. Means why this pupil is black? It makes the light which is entering into the eye to pass into the eye without allowing it to reflect back. Understood? That is the why the pupil appears black. Iris helps in controlling the amount of light entering the eye through pupil. What is the use of this pupil? Iris. Iris helps to control the amount of light entering into our eye with the help of pupil. What is the meaning of this? Suppose more light is entering into our eye. Okay, more intensity should not enter into the eye, which will damage the eye, isn't it? Suppose more intensity is entering into our eye, then this iris will be compressed, making the pupil is what? Pupil. This pupil is a small hole, isn't it? So this iris is like a muscular diaphragm, which can happen like this, isn't it? Which can be stretched and compressed. So when more intensity of light is entering into our eye, it will get compressed. Iris will get compressed so that the pupil size will decrease. So the required amount of light only it will allow to enter, so that the eye will not get damaged because of more intensity. When the lighting is very less, okay, then the iris will expand, so that the pupil size will increase. Pupil size will increase so that more light will enter. Understood, children? Like that, so it will control the intensity of light entering into the eye. Iris will control the intensity of light entering into the eye with the help of pupil. See, iris helps in controlling the amount of light entering the eye through pupil. In low light condition means lighting is very less. It is dim light. Then what the iris will do? The iris makes the pupil to expand so that more light is allowed to go in. And in case of bright or excess light condition, it makes the pupil contract and thereby prevent the excess of light not to go into the eye. That is the main use of this iris and pupil. That's why that pupil is a small hole. Okay, and the whole size will be changed with the help of iris. When low light condition, the iris will make the pupil to expand so that required amount of light will enter into the eye. And in more light condition, excess light condition, iris will make the pupil to contract so that only required amount of light will enter into our eye. Understood? Like that, this iris and pupil will protect the eye. Thus iris enables people to act as a variable aperture for entry of light into the eye. Iris enables people to act as a variable aperture. What is meant by variable aperture? Aperture means gap. Variable means which is not fixed. It will be changing. Isn't it? The small gap is aperture. The gap is not remaining same. It is expanding. It is contracting with the help of iris. So iris enables people to act as a variable aperture. How it is making it to act? Making it to act as a variable aperture for entry of light into the eye. The lens is hard in the middle and gradually becomes soft towards outer edge. So over the lens are hard in the middle. In the middle they are hard and gradually becoming soft when they are coming to the edges. So what type of lens they are? Can you tell? In the middle they are thick and coming to the edges they are thin. Yes, they are convex lens. Okay children? See. So the lens is hard in the middle and gradually becomes soft towards the outer edge. The light that enters the eye forms an image on the retina. The light which is entering into the eye is forming the image on retina. Where is that retina? See, back. This back portion. This is what? Retina. Clear children? So, the light that enters the eye forms an image. Where the image will form? We have learnt about lens, isn't it? So, if you take convex lens, it forms what type of image generally? Real image. Except when the object is placed in between pole and focus. Then it forms virtual image. Remaining all conditions, it forms real image. So here also, this lens are thick at the middle and thin at the edges. What type of lens they are? They are convex lens, isn't it? So it forms what type of image? Real image. So where the real image can be caught? A screen is required for formation of real image, isn't it? That is what we learned in our previous chapter, right? So here this retina, this is retina which will act as a screen for formation of image. Understood students? So this is retina for formation of image. Now, it covers the rear part of eyeball. Rear part means back part of the eyeball. The distance between the lens and retina, distance between this lens and retina is about, see, this distance between lens and retina will be about 2.5 centimeters. The distance between lens and retina is 2.5 centimeters. The least distance of distant vision is 25 centimeters. Here distance between lens and retina is 2.5 centimeters. Okay children? Right. So that is for any position of object in front of the eye, the image distance is fixed and which is about 2.5 centimeters. What is the meaning of this sentence? Just see here, convex lens if you take, will the image position remain same? Means image distance remains same for convex lens, whatever may be the position of object. Is it possible? No. Isn't it? As the position of the object changes, the position of the image also definitely changes. Yes or no? Yes. Once you recall the ray diagrams which we learned, recall the ray diagrams. When object is beyond center of curvature, where the image is forming, image will be formed between focus and center of curvature, isn't it? And when object is on center of curvature, image will be formed on center of curvature, C2, C1, isn't it? And when object is between focus and center of curvature, then image will be formed beyond center of curvature. And when object is on focus, image will be at infinity. And when object is between pole and focus, you are getting virtual image, isn't it? So according to the position of the objects, there being change in the image formation, that is distance of the image distance is being changed. Yes or no? But here if you observe, whatever may be the position of object, I am seeing this object which is at this distance, okay, where the image of this hand is forming for my eye, where this image is forming, this is forming on retina, isn't it? Where is that retina? At 2.5 centimeters distance from the lens, and image is forming at retina. Now if I am observing the far object there, okay, far some mountain is there, some tall building or mountain is there, I am observing that mountain, where the image will form, the tall building or mountain image, where it is forming in my eye, it is forming only on retina. Then also image is forming on retina only. Even if I observe near object, image is forming on retina. If I observe far object, then also image is forming on retina, isn't it? So what you understood from this? Irrespective of position of the object, image distance is fixed. Am I clear, children? You understood this? Whatever may be the position of object, for our eye, image distance is fixed. What is that image distance? 2.5 centimeters. What is meant by image distance? Distance between the pole and the image. That is image distance, isn't it? That means distance between the lens and the image. That is image distance. And here lens and the image is forming on retina. So this distance is fixed. Whatever may be the position of the object. Object is near the eye or far at the eye at infinity. But the image distance is fixed, which is 2.5 centimeters. Am I clear, children? How? How is it able to possible? How is it possible? How is it able to for the image to form only on retina irrespective of position of the object, whether object is near or object is far? What is making the image to form only on retina? How is it possible? It is possible only when focal length is being changed, isn't it? So according to the position of the object, our eye lens focal length is being changed. How is it possible? What is making that focal length to change without changing the retina here? What is making that? Yes, there is another important part in the eye, which is changing the focal length without changing the position of the lens or the retina. What is that part? Yes, very good. That part is ciliary muscles. Another important part is ciliary muscles, which makes the image to form only on retina. This is that part. What is it called? Ciliary muscles. Ciliary muscles is the part which is making the image distance to be fixed irrespective wherever the object is. The object image is forming only on retina because of ciliary muscles. See here. How can we get this same image distance for various positions of objects? Can you answer this question using concepts of refraction through lenses? In the previous chapter, you have learned that for different positions of object, the image distance remains constant only when there is a change in focal length of lens. Yes or no? Even different positions of the object, the image distance can remain constant. What I told now, only when there is change in the focal length of the lens. And further, the focal length of lens depends on material by which it has made and radii of curvature of lens. So we need to change the focal length of eye lens to get same distance for various positions of object in front of the eye. This is only possible when the eye lens is able to change its shape. So it can change the focal length of eye lens only when there is change in the shape of the eye lens. How does eye lens change its focal length? How does this change take place in the eyeball? Let us know. So the ciliary muscle to which eye lens is attached. See, this eye lens is attached here to ciliary muscles. Helps the eye lens to change its focal length by changing the radii of curvature of the eye lens. So which is responsible for changing the focal length of eye lens? What is responsible? Ciliary muscles. How? By changing this radii of curvature of lens. When the eye is focused on a distant object, ciliary muscles are relaxed. Relaxed means what? Stretched. When eye is focused on distant object, the ciliary muscles, they will get stretched, they will get relaxed, so that the focal length of eye lens has its maximum value, which is equal to its distance from the retina. What is that? 2.5 centimeters. Understood, children? When eye is focused on distant object, far objects, then the ciliary muscles will relax. Relax means get stretched, so that the focal length will become the maximum value. What is that maximum value? The distance between the lens and the retina, which is equal to 2.5 centimeters. The parallel rays coming into the eye are then focused onto the retina and we see the object clearly. See why he mentioned this point here? The parallel rays coming into the eye. Why parallel rays? Yes, very good. Here object is distrained, means object at infinity. When object is at infinity, then how will be all the rays, incident rays? They will be parallel. So he used that word parallel rays. So the parallel rays coming into the eye are then focused on to the retina and we see the object clearly. And when the eye is focused on a closer object, then what will happen? Ciliary muscles are strained. Strained means what? They will get compressed. Understood? When the eye is focused on near objects, ciliary muscles will be strained. Strained means compressed. Relaxed means stretched. See here. Relaxed means they will get stretched. Relax means stretched. And strain means compressed. When the object is closed, the ciliary muscles will get strained, means they will get compressed. Then what will happen? The focal length of eye lens will automatically, when they are compressed, automatically there will be decrease in the radii of curvature. Isn't it? Radii of curvature. And what will happen? It will get decreased. What? Focal length. Focal length will get decreases. The ciliary muscles adjust the focal length in such a way that the image is formed on retina and we see the object clearly. Understood, children? When eye is focused on near objects, automatically the ciliary muscles will get strained. When they get strained, there will be decrease in the radii of curvature. Automatically the focal length will decreases and it makes the image to form on retina. Very, very important point this one, children. I hope you are understanding, right? When eye is focused on distant object, then the ciliary muscles will get relaxed. What will happen to the ciliary muscles? They will get relaxed. Okay, when ciliary muscles are relaxed, focal length will increases. The focal length will become maximum, which is equal to the distance between the lens and retina. Okay, and when eye is focused on near object, then the ciliary muscles will get strained, compressed, so that it makes the focal length to decrease, and then also this makes the image to form on retina. So which is the main part responsible to form the image on retina, irrespective of position of the object? It is ciliary muscles. By getting relaxed when focused on far object and becoming strained when focused on near object. By adjusting the focal length, making the image to form on retina so that we can see the object clearly. Am I clear, children? This adjustment of focal length is called accommodation of eye lens. See here. So when the eye is focused on a closer object, the ciliary muscles are strained and focal length of eye lens will decreases. The ciliary muscles adjust the focal length in such a way that the image is formed on retina and we see the object clearly. This process of adjusting focal length is called accommodation. This process of adjusting the focal length is called. Very important question. Process of adjusting the focal length. This process of adjusting the focal length is called what is it called? Accommodation of eye lens. Is called accommodation. This process of adjusting the focal length. What is meant by accommodation? Process of adjusting the focal length is called accommodation. What for adjusting the focal length? To make the image to form on retina, whether the object is at far off distance or near off distance. By adjusting the focal length, we are able to, the eye is able to form the image on retina and enabling us to see the objects clearly. Understood? This process is called accommodation. However, these muscles cannot strain beyond a limit, and hence if the object is brought too close to eyes, the focal length cannot be adjusted to form an image on the retina. Thus, there is a minimum distance for distant vision of an object which is roughly equal to 25 centimeters as we have learned in activity 1. You all keep your textbook very near to the eyes. Can you see the letters? No. We have done this in activity 1, isn't it? Whereas if you move back at 25 centimeters distance, very clearly you are able to see the letters. Why? The focal length should be adjusted, no, by the ciliary muscles. When it is very near, they should get still strained and the image will form on retina. We can see the objects very clearly, but we are not able to see. And also, can you see far? How much distance the object is? Can we see? How much distance it is? Can we see the objects? No, isn't it? So there is a limit of this adjustment of focal length also. There is a limit for it, isn't it? There is a maximum and minimum limit. So the maximum limit is this 2.5 centimeters. It can adjust, it can relax. More than that it can't relax. So we can see the far objects up to certain limit, not beyond that. In the same way, you can see the near objects only up to certain limit, because the ciliary muscles can strain only up to minimum limit, not more than that. To minimum limit, the ciliary muscles will get strained, which makes the image to form on retina. More than that, it can't get strained. Even a spring also, you see. Can we stretch it how much we can, and can we compress it how much we can? No, it will have a maximum and minimum limit. In the same way, these ciliary muscles also, to adjust the focal length, to get relaxed and to get strained, there is a limit, maximum and minimum limit. So, up to 25 centimeters distance, it can get strained. More than that, if you bring near, the ciliary muscles cannot strain anymore. So, the image is not forming on retina. So, we can't see the objects clearly. I hope I am clear, children. You are understanding. Very important concept, this one. Okay. So, now tell me, islands, are they forming real image or virtual image? Here image is forming on retina, which is behaving like a screen, white screen. So what image it is forming? Yes, islands will form a real image. Islands will form a real image. Now, how does the image formed on retina help us to perceive the object without change in its shape, size and color? Generally, real images are what images? How the images will form, real images? Will they form erect or inverted? Recall our diagrams. Yes, real images will be always inverted. Always real images are inverted. Then, when you see any object in front of you, as the image is forming on retina, which is a real image, are you observing reverse, invert object? Are the objects appearing inverted? No, isn't it? You are seeing erect only. How is it possible? How is it possible? This is possible by another part of this eye. What is that part? Nerves. See, where are this? Optic nerve. Another part is optic nerve. This one. Another important part is optic nerve. What does this optic nerve is doing? Let us see. See, the image is forming is real image which is forming on retina. Isn't it? Real images are always inverted. But we are seeing with our eye erect object but not inverted object. How is it possible? What is happening? What is the use of this optic nerves? Let us see in our textbook. All see. The eye lens forms a real and inverted image of an object on the retina. The retina is a delicate membrane which contains about 125 million receptors called rods and cones. So retina is a delicate membrane, and what does it consist of? What it is consisting of? 125 million receptors. So retina is consisting of 125 million receptors, which are called as rods and cones. So 125 million receptors are called rods and cones. What are the use of these rods and cones? They will receive the light signals. What they will do? They will receive the light signals. Okay, children? Receive the light signals. And cones identify the color. No, rods are used to identify color and cones are used to identify the intensity of light. Rods are used to identify color. You are saying colored objects are not. That is because of rods. And cones are used to identify the intensity of light. That is the use of rods and cones. These signals are transmitted to the brain through about 1 million optic nerve fibers. Now these signals, after the image forming on retina, is being transmitted to our brain. By what? By these nerve fibers. How many nerve fibers are there? 1 million optic nerve fibers. These are approximately 1 million. 1 million optic nerve fibers are transmitting the signals to the brain. Then the brain interprets these signals and finally process the information so that we perceive the object in terms of its shape, size and color. So what the brain will do after receiving these signals? It will interpret. Okay, it will make the object in respect of its shape, size, color, everything. Means again the brain will What it will do here, it is forming what image? Inverted. That inverted image will again get inverted by the brain. Then what will happen? Here erect image is getting, sorry, erect object getting inverted image here. That inverted image is again making inverted by the brain. So it is again becoming erect, which is being done by the brain. Am I clear, children? So in its original size, shape and color. Am I clear? So eye lens itself changes its focal length in accordance with the distance of the object with the help of ciliary muscles. Now, is there any limit to change of focal length of eye lens? Limit is there or not there? Yes, as we discussed it, there is a maximum and minimum limit of change of focal length by the ciliary muscles. What is that limit? That we are going to learn in our next class. So these are the main parts. I hope you all understood, children. Have you understood all these parts? So what are the main parts we learned here is cornea. The outer protective membrane, thin membrane is cornea. Behind cornea, there is a, behind cornea what is there? Behind cornea, aqueous humor, a liquid is filled. Okay, that is aqueous humor. Behind aqueous humor and before the lens, there is another part called iris, which is a muscular diaphragm consisting of pupil, a small hole. Pupil, which is also called variable aperture, isn't it? So this iris will expand and contrast when there is change in the intensity of light. In dim light, this iris will make the pupil to expand, so that required amount of light intensity will enter into our eye. And whereas in more lighting, bright light, this iris will make the pupil to contract, so that contrast, so that required amount of light intensity will enter into our eye. That are these two parts. Okay, and these are crystalline lens, convex lens. It is convex shape. Okay, and this is retina for formation of image, and the distance between this lens and retina is 2.5 centimeters. Okay, and irrespective of position of object, always the image is forming only on retina because of ciliary muscles which are connected to the lens. Understood? The ciliary muscles are called accommodation of eye lens because they will adjust the focal length according to the position of the object. They make the eye lens focal length to adjust, to increase and decrease, so that the image will form only on retina. Clear, children? And the object we are able to perceive according to its original shape, size, color because of this optic nerve fibers, 1 million optic nerve fibers. Okay, they are transmitting the signals to the brain, and brain will interprets the information and makes to get the original size, color and shape. Okay, and also this retina consists of 125 million receptors which are called as rods and cones, where rods will intensify the color and cones will intensity of light. Clear, children? These are the main parts which you are required to learn for your physical science chapter. So this is our chart. Let us see the chart. Okay. You can see the chart now. Okay, children? Now observe the chart. This is our eye. So many parts are there. As I told, all that parts are not required for you. Only the main important parts, let us see, whatever we learned. See, cornea. This is cornea. Can you see, children? This is cornea. And here this is lens, crystalline lens. Okay? And can you see this small hole here? Hole like one, that is what? Iris, pupil. This is hole is pupil, and this one is iris. This is iris which is connected to the lens. This iris will make the pupil to increase and decrease, behave as a variable aperture by the iris. So this is that iris, and this is pupil, this is the lens, and this is cornea. Am I clear, children? These are the parts which we learned. And now coming back, the rare part. What is that rare part here? Retina. This is retina. You can see here, this is retina. Okay, children? And these are the nerves, optic nerve fibers, transmitting the signals to the brain. Okay, children? So this is our chart, human eye. You can see here that black ball, all you can see here. I hope I am clear, children, with this structure of human eye. Clear? So once you will read the textbook again completely, any doubt you can call me and ask. Okay, children? So in next session, we are going to learn the minimum and maximum focal length of eye lens. Okay? Thank you.